As I was saying, we've got to, again, with unlike denominators, we've got to find the common denominator. In this particular case, we could use 24. We just have to reduce it at the end. There is a smaller number, which is 12, okay? So it would work if you use 24. Now, how did I come up with 24, with 12 is I took 6, and the first multiple of 6 is 6. 6 times 1 is 6. 6 times 2 is 12. 18, and so on. Then I said, well, 4 won't go into it, but 4 will go into 12, so that I just found my least common denominator, which is 12. Okay? Now, the other way you can do this is by doing your prime factorization. For 4, it would be 2 times 2, and for 6, it would be 2 times 3. Now here's how you do this to find your least common denominator. You take what they have in common, which is a 2, and you write one of them down. Only one. Then anything extra, you list it as well. And then you multiply that to find your least common denominator. 2 times 2 is 4, times 3 is 12. Okay? So again, what they have in common, you only write one of them down, and then you tack on anything extra. Okay, so what did I multiply 4 by to get that 12? I said times 3, so whatever I do the bottom, I have to do the top. So 3 times 3 is 9. I multiplied 6 times 2 to get 12, so 1 times 2 is 2. So now I'm going to say 9 plus 2 is 11 over 12, and it will not reduce. If you'd used 24, you would have just had to reduce your fraction at the end. Okay, right here we're going to change. Again, this isn't how I was taught, but this is how they teach it now. So change this to a mixed numeral. 15 times 2 is 30, plus 7 is 37 over 15. Minus 5 times 1 is 5, plus 4 gives us 9 over 5. Okay. I look at this and I go, oh, well, 5 goes into 15. So 15 is my least common denominator. Okay. If you didn't know that, then you can do the factor tree. For 15, it's 3 times 5. And then for 5, it's just 5. It's just 5. Okay. They both have a 5 in common, so you only write one of them down. Then this one has a 3 left over, so you tack that on, and 5 times 3 is 15. Okay, so here our denominators stay the same, so our numerator stays the same. Here I multiplied 5 times 3, so I have to say 9 times 3 is 27. Now I'm going to subtract. 37 minus 27 gives us 10 over 15. Now I'm going to reduce both of them by 5. 10 divided by 5 gives me 2, and 15 divided by 5 gives me 3. Again, I could say 2 times 5, factor tree for 10, the factor tree for 15 is 3 times 5. Well, this gives us 1, so I end up with just 2/3. Same way. Okay. Use prime factorization, find the LCD. I just already taught that to you. But for 15, it's going to be 3 times 5. For 24, when you do the factor tree, okay, I don't care how you split it up. I'm going to do 4 times 6. This is 2 times 2, and this is 2 times 3. So you have 3 2's and a 3. Okay, to find our least common denominator, our LCD, they both have a 3 in common. I should have written the 3 under the 3. It would have worked out better. So I write that 3 down, and I tack on anything extra. I have a 5. I have 2, 2, and a 2, so 3 2's. Now what I'm going to do is multiply all this together. 15 times 2 is 30, 30 times 2 is 60, 60 times 2 is 120. Okay, so my new denominator is 120. Okay, so what did I multiply 15 by to get that 120? Well, here's my 3 and my 5 to give me 15. I had to multiply it by 2 times 2 times 2. Well, that gives me 4 times 2 is 8. So 1 times 8 is 8. Okay, what did I multiply 24 by to get that 120? Well, the 24 is these 3 2's and this 3. It had a 5 that we added on, so I multiplied it times 5. So 7 times 5 is 35. So now I'm going to add and get 43 over 120. 43 is prime, and 43 won't go into 120, so it's reduced. Okay. And this one right here, we're going to do 10. The prime factorization is 2 times 5. For 12, it's 2 times 2 times 3. Now you can do it on a factor tree. I just can do this in my head because I've done it for so long. But you're just going to do this and you would end up with that. Okay, to find the LCD, they both have a 2 in common, so you write it down. Now we tack on anything extra, which would be a 5, a 2, and a 3. It doesn't matter what order it goes in. It really doesn't, because you're just going to multiply it all out. This gives me 10 times 2 is 20 times 3 is 60. So this gives me 60. My least common denominator is 60. Okay. I multiplied 10 times 6. So I have to multiply the 3. If you didn't know how to do that, the 10 was 2 times 5. So this was what was extra, which is 2 times 3 is 6. 3 times 6 is 18. What did I multiply 12 by to get the 60? Well, the 12 had the 2, and the 3, so the extra was 5. So if I multiply that times 5, I just multiply that times 5, which is 35. Now I'm going to add that together. And I get 53. Again, you can go over here and do this. There's nothing wrong with that. This gives you 13, carry the 1. I can just do things in my head because I practice all the time. And that will not reduce, so we're done. Okay. Now this is just the exact same thing that we did with whole numbers, but it's harder because we've got fractions. So I'm going to do this one and then move on because, again, time, because we got out of school, we just don't have time for everything, so I'm going to have to cut some things out, and this is one of them. But I'll do one of them. Okay, so wherever I saw an X, I plugged 6 2/5 in. Okay, so this one I've got to multiply before I add. Okay, so that right side gives us 7. So in order to multiply this, I've got to say 1/4 times, I'm going to make this improper. 5 times 6 is 30, plus 2 is 32 over 5. Okay. I'm just letting this hang out over here. Alright, I'm going to do this part right here. You can multiply straight across and then reduce, no matter how you do it. I reduce within the problem. So I say 4 goes in itself 1 time, into 32 8 times. So I'm going to get 8/5 right here. And I'm just going to leave it like that for now. Now you can multiply straight across and get 32 over 20 and then reduce it, and it's still going to give you the same thing. Now I've got to add this 6 2/5 to that. So I'm going to make it an improper fraction. 5 times 6 is 30, plus 2 is 32 over 5. So 32 plus 8 gives me 40 over 5. But that's, oops, I was thinking ahead, sorry. But 40 over 5 gives me, does not give me 7, it gives me 8. So 8 is not equal to 7. So no, it's not a solution. SOLN, I'm really lazy on that. Okay? Just gets a little bit harder when you got all this. This one right here, probably, I should go ahead and do that. It's not that difficult. This section is just really long. Minus 2 over 21 equals 1/2 times 2 over 21. So I'm going to simplify that right hand side because it seems easier to me. I'm going to reduce it and then multiply. So you get 1 over 21. Okay, oh, my handwriting is getting messy. It's getting late. Because it's 1:15. So let's try this again. Let's write it as 1 over 21. If you'd multiplied, you would have gotten 2 over 42. If you multiply straight across and then reduce, it still is going to give you 1 over 21. Right here on this side, okay, so hold on just a second. Let me take a piece of paper here and cover up that one side right there, because now we're just dealing with this side. I've got to find a common denominator, which is going to be 21 because 7 goes into 21. Seven goes into 21 3 times, so 3 times 1 is 3. This here has the same denominator, so I get 1 over 21 on the left side. On the right side, we have 1 over 21, so it checks out, so it is a solution. Okay, and I am going to quit there. That is 1.2. That was probably the longest section.